Okay, so loosely speaking, two functions are inverses if they undo each other. So more precisely, what this means is their composition, if you take the composition of the two functions, they undo each other. So in other words, if we want to see, let's see, functions f and g are inverses if f of g of x, the composition, this is an open circle, f of g of x equals x, meaning that when you apply both of these functions to the input x, then you get the output x also. Okay, so it has to be the same, no matter what the input is. And what that means is, remember f of g of x, you go f of g of x. So what happens is, x goes into g, and then that whole thing goes through f. So x is going to go through the g machine, and then it's going to go through the f machine, and the f machine should undo everything the g machine does to give us back x. Okay? So that's no problem. But also, it doesn't just work one way, it has to work the other way also. We have to look at g of f of x, and that should also equal x. So that means x is going to go to the f machine, and then the g machine is going to undo everything that we did here to give us back the original input x. So that's how we verify that two functions are inverses. We have to look at the composition both ways and see that the output is the same thing that we put in. So f and g are inverses if their composition one way gives the output x with the input x, and the composition the other way gives the output of x if the input's x. So here, I need to see, I want to verify that these two functions are inverses, so I'll look at f of g of x, and I want to see that I get x. If I do, that's good. But also, I have to see that g of f of x equals x, okay? If they do, both cases, then they're inverses and we've verified that they are. So f of g of x is f of 2x minus 1. And now we plug 2x minus 1 into the f function. So I plug it in here. So I get 2x minus 1 plus 1 all over 2. In the next step, I can drop these parentheses because it's like distributing this invisible 1 in the front. So I've got 2x minus 1 plus 1 over 2. Negative 1 plus 1 is 0. 2x divided by 2 is x. So that's good. That one checked out. The output of that composition is x. I'll do the same thing over here. I've got g of f of x. That's g of f of x, which is x plus 1 over 2. Then I put x plus 1 over 2 into the g function right there. So I've got 2 times x plus 1 over 2 minus 1. So I've got to multiply these two things, and remember that 2 is a fraction, 2 over 1. So the 2's cancel when I multiply. So I just have x plus 1 minus 1. And again, because of this invisible 1 in the front, if I distribute it, I'd get rid of those parentheses. 1 minus 1 is 0. So the output is x, and that's what we wanted. So the composition results in x in both cases if the input's x. Therefore, these two functions are inverses.